This is Precalculus chapter 10, lesson 3. Guys, I'm on page 637. 637. Okay, this entire chapter is on the application of trigonometry. Basic trig ratio. Sine and cosine really is mostly what we are dealing with. This lesson is on the complex plane. So normally we have the x and the y coordinates. However, now we're going to have the x and the I coordinate. This is your complex plane, where I is your y axis. All right, so we're going to talk about complex numbers here. What's the proper form for complex numbers? Real plus imaginary, right? So 4 plus 2i is proper form. Real always comes before imaginary. So this is a complex number, right? Your 4 we would graph on the x-axis. So that first real number is the real value on the x-axis. The coefficient to I is what we would graph on the complex axis. All right, so I want you to think vectors. Do you remember vectors from last year? Yes? Vectors? So what value goes with, remember we use this as R and that as U? Remember we had something R plus something U? We're not going to use that this year. We're going to use the X and the I. We're also going to use different formats of it, but that's not for today. So I want you to think vectors, right? Such that this is a vector that from the origin to that point. So now we can probably draw a right triangle. Where do we always draw the right triangle to? The x-axis, 100% of the time, the x-axis, never the y-axis, all right? So when we had vectors, remember this was our magnitude, this length was the magnitude, and theta was our direction. Yeah, you remember that? Do you remember it now? And we always rotate from that positive x-axis. We rotate counterclockwise, right, is positive. Clockwise is negative. So this is a tie-in to physics, really. This is the math of physics. We're also going to call this the modulus. So this is just a new term. The modulus. It's really the hypotenuse of a right triangle, right? So think Pythagorean theorem. And if I were to calculate the x value, what trig ratio do I use? X goes with? No. What trig value? Trig ratio. X goes with cosine. X goes with cosine. The y value goes with sine. So that's what you're going to think, right? The x goes with cosine. That y goes with sine. So if I am calculating the x value, I'm thinking cosine. If I'm calculating the I value, not the R or the U or the X or the Y, it's now I, right? If I'm calculating the I value, I'm thinking sine. All right? So this is now, it's the magnitude in physics of a vector. It's a modulus in precalculus. Simply, guys, it's really just the hypotenuse of a right triangle, right? Just big words for the hypotenuse of a right triangle. All right, so when we have complex numbers, we can calculate the modulus by using Pythagorean theorem, right? But when we're in the complex system, we're going to call it, instead of utilizing the Pythagorean theorem, we're going to call it the absolute value. So the absolute value of any complex number is simply utilizing Pythagorean's theorem. If I were looking for the absolute value, I need to get my iPad, y'all. I think I left it plugged in at home. Never mind. Thank you for being so sad for me. Because I have this huge textbook that now I have to really... Did I plug it in? Y'all, you know me. I'm like, no way I plugged it in yesterday. Wait, it's on my desk. I have it. Yay. Thank you, Lord. The Lord is good, always. Even if I left it at home, he's good, right? Okay, this is much easier to hold than that textbook. All right, so if I were calculating the absolute value, I simply want you to think Pythagorean theorem. That's all I want you to think. All right, but let's actually look at the example in the textbook while my iPad is thinking and I try to get there. So this is example 1 on page 638. All right, so new words, but things you already know. Right? Yeah. Thank you. Absolute value of a complex number. When we use the absolute value, we are calculating the modulus. I want you to think Pythagorean theorem. Got it? All right, so look at the two examples, example 1 in the textbook. If I wanted to calculate the absolute value of this number, I'm really calculating the modulus. It's the square root of 3 squared plus 2 squared. Right? Because wouldn't it be 3 squared plus 2 squared equals the modulus squared? Mm-hmm. Right? And you take the square root, both sides, so that you're really thinking you're calculating the modulus, or the magnitude, or the hypotenuse of a right triangle. All right, so that's 9 plus 4. 9 plus 4 is? 13. So it's the square root of 13. So my modulus, or the absolute value of this complex number, the absolute value of this complex number is the square root of 13. Yes, ma'am.
And you don't use the I, so it wouldn't be 2i squared and then make the
Correct. Correct. I does not go in this formula. Like x doesn't go in the formula. So we are not squaring I, because I squared is negative 1. I squared is negative 1. So yeah, but we're not, no i's.
So you don't do anything with the I, period?
No, the I just tells you what axis it goes on. Got it? Yeah. Okay. That's all I tells me. Tells me what axis. All right, look at example 2. 4 minus 5i. What quadrant is that in? Fourth, because your x is positive and your y value, which is now our I value, is negative, so it's in quadrant 4. The modulus, ladies and gentlemen, is always a positive value, because even though my coefficient for I is negative, when I square it, it becomes positive. So if I'm calculating the absolute value of that number, it's the square root of 4 squared plus 5 squared. Well, it's really plus negative 5 squared, but I don't need to worry about the sign, right? All right, 4 squared is?
16.
16. 5 squared?
25.
25 and 16. That's your answer. Leave it in its most simplified, radical form. Do not convert that to a decimal. If you could simplify it, you would simplify it. All right, that's the first concept from this lesson. Is it hard? No. So what is the absolute value of any complex number? Nathaniel, what's the absolute value of any complex number?
In the book somewhere.
Nathaniel, I want you to use your brain, not the book. Come on.
Value of any complex number.
Yes, absolute value of any complex number. What if I asked you, what is the absolute value of negative 2 plus 5i? What would you do? Thank you, Michael. Okay, I really want you to engage your brain and pay attention with all your brain cells, okay? Michael, what is it?
You take the absolute value of the equation and then square both the terms. So you'd square, it'd be like 2 squared plus 5 squared.
Right. What did I say to think? Think what? Pythagorean theorem. Absolute value. Tie that in to Pythagorean theorem. You're calculating the modulus. All right? The modulus matters when we get to vectors. Because remember, we went between rectangular and polar form last year. So rectangular form looked like 6 at 270 degrees, 6 being your magnitude and 270 degrees being the direction of the vector. Do you remember that? Or we did, that's right on that. Or we did 5r minus 2u. Hey, Jake. And this just gave us our x and our y coordinate. Do you remember that? Now we're going to have vectors that look different. They're going to be in your absolute complex form. They're going to be in your complex form. So they're going to be something like 2 plus 5i. So this is more like your rectangular form. Let me write it next to it. 5 minus 2i. That's what this one's going to look like now, right? We had it in this form last year. And now it's going to look like complex form. Think vectors from last year. Or we are going to have it in what looks like polar form. And they also call it polar form here. It's going to be r, and that r is the modulus. Cosine theta plus I sine theta. This is going to be our polar form. So we're going to go between polar form and complex. Just like we did last year, we went between rectangular and polar form. It's just going to look different, okay? But they're so similar. Remember, the cosine goes with your x, the sine goes with your y, and we just have an I. Theta represents the angle. That's right. Just like we had the angle in this polar form, we're going to have the angle. Just like we had the magnitude in this form, we now are going to have the magnitude here, and we're going to call it the modulus, which is just the absolute value of your complex number. Right? I can calculate my modulus if I've been given the complex form by using the absolute value, or Pythagorean theorem, right? You see the tie-in from last year. All right. So example 2, it says find the polar form. And it's in complex. So it's negative square root of 3 plus I. Just like last year, I'm going to tell you again this year. Draw the triangle. Draw it. All right, so this is negative square root of 3, positive 1. So I know I'm in quadrant 2. So when I get to theta, it better be in quadrant 2. All right. Now, is this a Pythagorean triplet that you are aware of? 1 square root of 3, 2. We already know our modulus. We did not even have to do Pythagorean theorem because we knew the triplet. Right? Okay. Can I know what theta is? What is it, Michael?
So it'd be 90 plus 60, because it's a 30, 60, 90 triangle.
It is okay, and so here's your 30 or pi.
So it'd be 180 minus 30.
Pi over, we're in radians, pi over 6.
So,
All right, so you go all the way to pi.
so 5 pi over 6?
5 pi over 6. That is correct. Look, did we even use our calculators? No, we used our brains.
How did you do that pi over 6 again?
Okay, let's talk about it again. I'm going to erase that one. All right, so we knew that opposite one was your 30-degree angle. And in radians, it's pi over 6. 30 degrees is pi over 6. So we go to whole pi minus a sixth. All right, so look, it's 2 at cosine 5 pi over 6 plus I sine 5 pi over 6. So we have put this complex number in polar form. That's it. That's it. That's the answer.
If it wasn't on the units before,
Then you might have to use your calculator. Yes.
and do an inverse.
And do the inverse. Yes.
Can we do
Yes.
an inverse?
Well, the next one isn't on.
Okay.
Example 3 is not on the unit circle. All right. All right, so -2 plus 5i. What quadrant is this in? Yeah, -2, that's plus 5. Always drawing our triangle to the x-axis.
And we know it's in quadrant 2.
How do we know it's in quadrant 2, ladies? Yes.
Because the -2 is on the x, and then the 5i is on the y. It's positive.
Got it? Does everybody understand that? How we know what quadrant it's in? Okay. I want to go to r cosine theta plus I sine theta. The i's in there because we're now in the complex system. I need r, I need theta. How do I get r? Square root, keep going.
-2 squared,
Which is
4.
positive 4 plus,
5 squared,
which is,
25.
and that is
29.
square root of 29. That's my modulus. Remember, this is my modulus. That's the absolute value. I want you to keep thinking those words. It's the modulus, right? It's last year the magnitude. In physics, it's the magnitude. Okay? Lots of words. I know. Modulus, absolute value. Modulus, absolute value is just Pythagorean theorem. Okay, so this is square root 29. This is going to be my theta. So now I do need to use my calculator. In radians. We're in radians. Make sure your mode is radians.
Well, how come it's not an angle? Like it's not a degree?
Because we are still in radians. They still want us to be in radians. Okay, can you do this in degrees? Yes, you can. But all of this will always be in radians. Okay, in order to get this theta, I have to have this one and go all the way to pi and subtract that from it. All right, you always use the tan. Because if you miscalculated the modulus, now your angle is going to be wrong. Always use inverse tan. And if you do tan inverse. When I do the tan inverse, what quadrants am I in?
1 and 3.
1 and
4.
4. All right, so if I put my negatives in here, you know where it's going to give me an answer in? The fourth quadrant. Don't put the negatives in. Just figure out what the angle is. Okay? So it's opposite over adjacent 5 over 2. What is the inverse tan? Say it.
1.19.
1.11. 9. Yes. 1.19. All right, I want to go all the way to pi and subtract the 1 point. So take pi minus that value. So second pi minus the second answer. And I get 1.95 plus I sine 1.95. Is that what you get? Actually, they give us in 4 decimal places because we're in trig. 913, 913. Go to 4 decimal places because we are in trig. All right, you got it so far? Seems straightforward, right? Makes sense?
So that's it?
Well, not yet.
What, like that's it for this?
That's it. That's it for this one. Yes. So that's when it's not on the unit circle. All right, Ashley, got it? Not on the unit circle, you're just going to do the inverse tan. On the unit circle, you're going to use your brain. Okay, now, the next part of what I'm going to teach follows the rules of exponents. All right? We're not going to do a proof. But if I have x squared times x fifth, multiplication is?
Addition.
Guess what? Multiplication of polar forms is what? Addition of theta.
What?
Yes! Multiplication is addition. Division is?
Subtraction.
Guess what? When we have, yes, we're going to subtract our thetas. So when we are multiplying polar forms, we're going to add our thetas. We're going to multiply our moduli. But we're going to add, yeah, that's, I don't really like, it's moduluses, but that's really not how you say it. So when we multiply, we're going to add our thetas. When we divide, we're going to subtract our thetas. But we are going to multiply our moduli, our R values. Got it? So it's the same rules. And y'all, that's the last 2 examples, multiplication and division. Okay. All right, so now I'm on page 641. So I want you just to remember multiplication is addition, division is subtraction. But I have taught you that for so very long right now, by now. Okay, so now we have 2 values, both in polar form. So we have Z1 and Z2.
Wait, where are you putting the numbers?
Example 4. And the instructions are to find Z1 times Z2. All right, for the moduli, I'm multiplying. It's going to be 2 times 3 on the outside of the big parentheses. Because multiplication in the inside is only addition. On the outside, we're multiplying our moduli. Got it? Mm-hmm. On the inside, we are adding our thetas. So it is cosine 5 pi over 6 plus 7 pi over 4 plus I sine 5 pi over 6 plus 7 pi over 4. Common denominator. We just need a common denominator, which is 12. You agree? All right, so we're going to multiply this first one by 2 over 2, this second one by 3 over 3, and what I get here is the same number I'm going to get here. Okay, so it's 6 times cosine, that's 10 pi, okay, we know it's going to be over 12. That's 10 pi and 21 pi to give me 31 pi. So it's 31 pi over 12. Got it? 10 pi plus 21 pi. So it's going to be the same for the sine. 31 pi, I did 311. 31 pi over 12. That's it. Multiplication is addition of theta.
So that's the answer.
That's the final answer.
So there's like, those are on the unit circle, so there's no way to go into the unit circle values for those. You're not gonna-
Right, right. But could you put that in polar form?
Yeah.
I mean, could you put that in complex form?
Yeah.
But you could. Okay, maybe the next one will go backwards. The next one we're going to go backwards and put it in polar form. I mean, put it in complex form. All right, so that's multiplication is addition. All right, division is,
Would you put it in complex form after you multiply them?
no, we don't have to, but you're going to have to know how to do that. You can leave it in polar form. You can leave it in polar form. But it is a possibility that I may ask you to,
Would you want us to do it after we multiply them?
no, leave it in polar form. However, I may give you a polar number and ask you, what is its complex form? Right? Okay, we're going to look at that in a minute. Look at example 5. And actually, we'll take the solution for example 5 and we'll go and put it in complex form. Okay? All right, now we want Z1 divided by Z2. All right, y'all can see what they are. Z1 is 10 cosine pi over 3 plus I sine pi over 3. Z2 is 2 cosine pi over 4 plus I sine pi over 4. All right, our moduli we're literally going to divide, right?
Yes.
We're literally going to divide. So that equals, 10 over 2 cosine. Now is when we are going to subtract our thetas. So it's pi over 3 minus pi over 4 plus I sine pi over 3 minus pi over 4. All right? Now we need a common denominator to subtract them. 12. So this one's going to be 4 over 4, and this one's going to be 3 over 3. So that's 5 cosine. Whatever I get for this one, I'm also going to get for that one. It's the same subtraction. All right, so it's over 4. It's actually over 12. So it's 4 minus 3 is just pi. Plus I sine pi over 12. Crazy stuff, isn't it? Okay. So now, let's put this in complex form. What quadrant is pi over 12 in? So this is pi over 12. This would be my x value. This would be my I value. Here's 5. We're in radians. So how would I solve for my x value? What is it, Will? X value. Cosine of pi over 12 equals x over 5 You could. I would do simple trig ratio. Multiply by 5. I don't know that you get the x value though. We need the x value. No, you're gonna get the ratio for the half angle.
Okay.
You're not gonna get the x value. All right, so yes, leave it in radians. So what's 5 times the cosine of pi over 12?
I got negative 4.219.
I got 4.8.
You shouldn't have gotten a negative because pi over 12 is
Oh wait,
I got 4.82.
4.82.
Yeah.
yes.
Okay, so complex would be 4.82. I know my I is going to be positive. Yeah, so it's going to be 5 times the sine of pi over 12 is going to be our I. Because the sine of pi over 12 is opposite over hypotenuse. What'd you get, Nathaniel?
1.294.
Thank you.
Okay, so you can go from polar to complex. We use cosine sine.